Okay, welcome to 3.8 Part 2, where we will be using inverse matrices to actually solve a system of equations. So, here I have a system of equations, right? And we know that we could use substitution, elimination, graphing, or Cramer's rule, that's what we learned with the determinants, to solve this. So this is just going to be another tool in your toolbox to solve. What you're going to do is make a coefficient matrix, which is just like when you did the determinant one. So it would be, -2. And since there's not a coefficient written in front of the y, I know that it's just a 1. Same thing with the x and the second y, so 1, 1. These are the coefficients to x and y. So I'm going to go ahead and write that as a matrix for x and y. And then it equals, we're going to call these the constant, and it's going to be 9 and 3. Write that as a matrix. So what you've done now is you've actually written an equation that needs solved. So let me ask you this, okay? Random example to the side here. If I had given you 1/3 x, equals whatever, doesn't matter, you would say that you would multiply by the inverse of 3, or the reciprocal of 1/3, okay, that's also known as the inverse here, so that you can make that 1/3 cancel. So I'd multiply by 3/1 on both sides, because whatever you do to one side, you have to do to the other, which will allow that to just be x equals 27, or 27/1, right? This is just an equation, so you have to do the same thing. So if you remember yesterday, I was talking about how when you have this 1001, that's like, quote, canceling, right? That's what's going to happen here. So you're going to need to multiply by the inverse of this matrix so that you can make it, quote, cancel. So first I'm probably going to need to find that inverse matrix equation. So again, that formula is 1 over the determinant, which is -2 times 1, minus 1 times 1. Switch this diagonal, switch the signs on the other diagonal. Let's go ahead and simplify. And that's going to be 1 over -3. And then we will distribute. So that'll be -1/3, +1/3, +1/3, and +2/3. So that is the inverse. What I'm going to do now is multiply that inverse to my equation. And so first I'll multiply it here, which I'm kind of squeaking it in here. My -1/3, 1/3, 1/3, 2/3. Okay, and you can go ahead and multiply this, but assuming that you did your inverse matrix correct, that's going to cancel. Whoops. That's going to cancel, so this is now gone. However, whatever you do to one side, you have to do to the other. And this is where you have to be really, really careful with matrix equations. Remember that I said that when you multiply matrices, order matters, right? So when you multiply this, because you multiply it on the left side, you need to multiply on the left side on the right side. So what I have now is x, the matrix xy, okay, that just came from this guy, is going to equal the inverse matrix times your constant matrix. Now you just have matrix multiplication. So if you like matrix multiplication, this will be pretty easy for you. Row, here, let me switch colors. Row times column. So -1/3 times 9. Let's see, I'll write this here, I guess. -1/3 times 9 is going to be -3. Plus 1/3 times 3 is 1. Okay, then I'm going to do the other row and column. Second row, first column. So that'll be 1/3 times 9 is a +3. and or 2/3 times 3 is 2. Go ahead and simplify that matrix. So -3 plus 1 is -2, and 3 plus 2 is 5. Okay, and this is an equation, so it equals the matrix x, y. And here's the cool thing. From there, it just matches up. X is -2, y is 5. So when I write my answer as a point, it's -2, 5. That's your answer. When you do the, I think, if you have a system of 3 equations, inverse matrix can be a little easier sometimes, and you get your x, y, z, but those take quite a bit of work, and there's none of those on your homework, so we'll call it right there.